So for project 3, we decided to do our project on Target and predicting what their sales would be for the year 2022 based on years from 2016 to 2021. We decided to run our analysis on several variables to see what correlates and a dummy variable as well.
So as you can see through our Excel file, we have plenty of variables to choose from, but this also took a lot of research. We went into actual just Target's website and we got financial records, and we also used a words database to get other things that we couldn't find just from the financial records. And having these two things as a part of our research really helped because we had tons of different things to look at and give us options of what we think would be great variables in order to have a great correlation, which would lead to a really good regression analysis in order to predict what sales would be for 2022.
So for the dummy variable that we used whether the targets were open on Thanksgiving Day. To understand this presentation, you're going to have to understand a few definitions that are going to be said throughout the presentation. Those 3 definitions are correlation analysis, which is a method that is used to discover if there's a relationship between 2 variables and how strong that relationship is. The next is regression analysis, which goes off of correlation analysis, and it's a statistical process for estimating the relationships between a dependent variable and independent variables. And then lastly, there's multicollinearity, which is used in the correlation analysis part to determine which 2 independent variables are too highly correlated to make an estimate on what the dependent variable is. So now we're going to go to talking about why we eliminated certain variables and why we chose other variables for the regression analysis.
Correlation, she means.
Correlation analysis. That's you, Chris.
Yes, you want to go ahead?
It's Jesus. Like,
Oh,
you gotta do the first.
My bad. Okay, so now that we ran the correlation, we wanted to run the conditional formatting to make sure we highlighted which cells had correlation to them. So for our conditional formatting, we used 0.9 as our cutoff. And this allowed us to see which variables were correlated to each other and which were heavily correlated to others. So right here, we saw that there were 3 variables that were usable, and Chris will talk more about this.
Okay. So first off, we had all these variables in this column that are highlighted green were highly correlated with sales. And so to eliminate some of the variables, we had to see if they were correlated with each other. So because of the multicollinearity, we had to test, well, check and see what variables were not correlated with each other and were under 0.90. And that ended up being total number of stores, apparel and accessories, and earnings from continuing operations before income taxes. And as you can see,
linearity happened, we had to choose between one of those 2 independent variables. And that's why we chose, I believe it's apparel and accessories over the other independent variable. Am I correct?
Right. So for instance, right, under earnings from continuing operations before income taxes, it is correlated with total number of stores, but it's under 0.90, so it was a good variable. Also, it was correlated with apparel and accessories, but it was under 0.90, so that made it also a good variable. Also,
do you want to explain about what the ones are?
I'll go ahead and explain about that. Whenever you see a 1, it basically means that whatever 2 variables meet at that point are the same, basically that they 100% are correlated to each other. But everything besides that does resemble correlation.
So now after you do this correlation analysis, you're going to use the variables that you chose and go into the regression analysis, which gives you the ANOVA table and the R-squared variable, the F significance, and p-values, which now Abby and Sean are going to discuss.
One more statement. Total number of stores was highly correlated with apparel and accessories, and that was under 0.90 also. So we took these variables and sales, and then we added it to a table all together so we can run the regression analysis.
Yeah, and for our regression analysis, you can see the R squared. And essentially what R squared measures is that's measuring the correlation between the independent variables that we chose to run the analysis with and the dependent variables that we're trying to find. So the higher that the number is, that tells us that it's much more correlated and basically lets us know that we chose the right variables. And if that number was a little bit lower, then we would pretty much, stop where we were, go back and try to figure out which variables we ended up pretty much missing, because that would mean that the ones that we chose didn't really have any type of correlation with what we're trying to find. And then after you go past that, we have our F significance. And with our F significance, that doesn't necessarily look at one particular variable or look at the sum of the variables. That's more so looking at the entire ANOVA table entirely. So looking at the equation that you can see below in the Excel. So that lets us know pretty much if the formula that we've created based off of the data that we've been able to discover, letting us know if it's going to accurately predict a potential outcome.
Which is why these are all highlighted in different colors to make sure that these values are acceptable and that we can go on with our project.
Right. And with significance F, it needs to be at least 0.05 or below in order for us to really understand if we are going to have a really good equation or not. So as you can see in our Excel, it's a 0.00. So we know that it is going to be a really good equation. And that kind of follows into the p-values as well. Instead of it being the entire equation in full, our p-values explain to us whether or not our coefficients or our variables are going to be really good for our equations. And also along with the significance F, p-values need to be 0.05 or below. And as you can see with our p-values, they're all 0.03, 0.02. They're all below 0.05. So we know that what we have for our variables are going to be really good for our equation.
So now that we've ran through all of the data regression and made sure that our equation is usable and that we have good coefficients, we can move on to our equation. So the equation that you see first is with us using the y-intercept and the coefficients that we got. And the second equation you see at the very bottom that has 2022 is basically our expected outcome, our sales for the year 2022. And the numbers you see right there, we actually got by calculating what our averages were. So we took our information from 2016 to 2021. Right here, you can see that we use the total number of stores. And each year, since it is a company that's growing every single day, they open new stores. We took the average of how many stores they open per year. And we did the same for apparel and accessories. And we basically took the average of how much it increased per year as well. And we did the same for operating operations. So on the right here, you can see that we took those percentages or those decimals. We got an average, and then we applied that average to the last year of our information, which in this case is 2021. Once we took those numbers from 2021 and multiplied them times our average increase per year, we took those numbers and we applied it to our equation. And if you click on regression results, you can see that once we put it into the equation, we got our new number, which if you could zoom in, because I can't see very well, you can see that it's 114 billion.
Mm-hmm.
And you can see that that is our expectation, our estimate for what 2022 year sales could be for the next year. Now, of course, this is just a prediction. This can be more or less depending on what factors contribute to that year's sales. And this can change because of the market or, for example, the pandemic that just happened. But this is a good expectation. This is a good estimate of the sales for 2022. And we got this all from running the correlation, running a data regression, and using the correct variables.
I think it's also important to note that just because there's a correlation in the data doesn't always mean causation. So that's why we had to pick different ones, and we had to run the regression to make sure that the things that are correlated actually were able to be ran.
Yeah.
So also another thing to note with the y-intercept in particular, if you do a lot of projects like this, it's not abnormal, but not typical to see a negative y-intercept, especially whenever we're predicting cells. So that was something that we ran into and had to discuss and figure out why it was negative, because it was confusing at first. But we came to the conclusion that since we picked a lot of different variables, independent variables that are a positive prediction in cells, the y-intercept has to account for the negative prediction in cells. So that's going to account for depreciation and loss of certain inventory and stuff like that. So that's why it's negative. Yeah.
Awesome. Well, we good? Anything else?
I think that's it.
Awesome. Well, that's all.
So to talk about the equation that we ended up with after doing the regression, we had to use our coefficients. Our coefficient in a regression equation tells a change in the value of the dependent variable in relation to the units and change in the independent variables. So for our y-intercept coefficient, we enter it here in our equation just as itself. Then we will add it to a variable number times its coefficient. So for total number of stores, for this particular one for 2021, it was 1,926, and we multiplied that times the coefficient for total number of stores. We also did that the same thing for apparel and accessories for 2021. That total, we multiplied it times its coefficient. Also for earnings from continued operations before income taxes. We took the number for 2021. I have to show you here. And we multiplied it times its coefficient. Then we added all those together, and that gave us our prediction. And our prediction, which you can see is right here, is similar to the actual results for the year for Target 2021. Also chose a random year and did the same, entered the same numbers for the equation for 2018. That would be these numbers right here. This was our result based on our equation. And it is very similar to the results from 2018.